I feel like we're all getting distracted.
How so?
You open your phone, you scroll through your feed, and it's just this endless chatter about, look what this chatbot said, or watch this car try to park itself.
The shiny object problem.
Classic. It's all very cool, don't get me wrong. I love a good gadget. But after digging through this massive stack of reports on xAI and Tesla, I realized something. We are totally missing the forest for the trees.
I think you're right. We focus on the gadget right in front of us, the app, the car, and we miss the colossal infrastructure being built behind it.
Exactly. And the sources we have today, they paint a picture of something much, much bigger than just a better ChatGPT or a smarter Tesla. It looks like.
Well, it looks like the construction of a single unified machine, one designed to automate intelligence itself.
And that's the term they're using, right? The Singularity stack.
The Singularity stack. That's it. Sounds like science fiction, I know. It does. But when you look at the documents, it's actually a very rigid, very specific tripartite strategy that Elon Musk is deploying to reach artificial general intelligence, AGI.
And that's our mission for this deep dive. We're going to unpack this stack layer by layer because the timeline in these reports, it's startlingly tight. We are not talking about 2035. We're talking about 2026.
Which is basically tomorrow in tech time.
Right.
And to get it, you have to stop looking at these as separate companies.
Right. Not a car company and a software company.
You have to see them as organs in a single body.
That biological analogy really helped me wrap my head around it. The sources break it down into three pillars. First, you have xAI. In this stack, xAI is the brain.
The reasoning, the software, the pure intelligence.
Then you have the body. That's Tesla. It's the physical part, the interaction with the world through the Optimus robots, and the eyes, the video perception from the car.
The kinetic side of the equation.
And the third pillar, which often gets left out of the AI conversation but is crucial here, is Neuralink.
The interface, the high bandwidth connection. The stated goal in the material is just fascinating. It's about making sure that as this digital intelligence scales, humans don't just become, obsolete.
And attempt to merge, or at least keep pace, with the brain being built at xAI.
It's a wild concept, brain-body interface, all developing in parallel.
But what really grounded this for me was seeing that this isn't just a whiteboard sketch. The scale of the infrastructure being built right now is hard to comprehend. Analysts are calling this the gigawatt era of computing.
That shift is so vital to understand. For the last 20 years, we've been in what you'd call the megawatt era. A data center was a big building, sure, but nothing that would drain a whole grid.
And now?
Now we are entering a phase where a single AI training cluster can demand as much power as a major American city.
Which brings us to Colossus. I love the name. Very 1950s sci-fi.
The machine that will take over the world.
But this is the real facility xAI, built in Memphis, Tennessee. And the first thing that jumped out at me wasn't even the tech specs, it was the speed.
Elon speed, as the reports call it.
Yeah. I mean, anyone who's tried to renovate a kitchen knows how long that stuff takes. A data center this size normally takes years. 4 years is standard.
Planning, permits, construction.
Yeah. xAI went from just dirt to a functional supercluster in 122 days.
It's unprecedented in industrial construction, and it just signals the urgency here. They aren't just building a server farm. They're trying to brute force their way to AGI before Google or OpenAI can catch up.
Let's get into the guts of Colossus, because the hardware specs here are just heavy. Currently, the reports say it's operational with somewhere between 100,000 and 200,000 NVIDIA H100 and H200 GPUs.
Which on its own is already one of the most powerful systems on Earth. That is a staggering amount of compute.
But the expansion plans.
Yeah.
That's what stopped me in my tracks. They are targeting a cluster of 1 million GPUs.
1 million.
1 million.
And that is where we hit that gigawatt reality. To put that in perspective for you, 1 gigawatt is roughly the peak energy demand of the entire city of San Francisco.
But pause on that for a second. One facility in Memphis, training a digital brain, will consume as much electricity as a tech hub with hundreds of thousands of people, hospitals, trains, everything.
Precisely. And that density creates a massive engineering nightmare. Heat.
Right. My laptop fan sounds like a jet engine if I open too many tabs.
Now imagine 1 million of the most powerful chips in the world running at full throttle. You are basically building a heater the size of a stadium. Electronics do not like heat.
So how do you cool it without melting the building?
No, it can't use air anymore. Not at this density. The reports mention they've partnered with Supermicro for advanced liquid cooling. The liquid has to touch the chip plates directly to pull the heat away fast enough.
It's like a radiator in a car, but just on this massive industrial scale.
Exactly. And then you've got the networking problem. It's not enough to just have the chips, they have to talk to each other.
Latency.
Right. If you have a million brains but they can't communicate, you don't have a superintelligence, you have a crowd. With a million chips, that traffic jam is astronomical. So they're using NVIDIA's Spectrum-X Ethernet to keep the whole thing synchronized.
So why? Why go to all this trouble, build a San Francisco-sized heater in Memphis? What's the objective?
The objective is compute velocity. xAI is betting that by scaling up the sheer amount of brute force calculation, they can train models that are simply out of reach for anyone else. Specifically, this whole thing is for training Grok 5.
Grok 5, the new flagship model.
A 6 trillion parameter model. The theory here is that quantity has a quality all its own. You make the brain big enough, and you get a leap in intelligence reasoning logic that smaller models just can't match.
So xAI is building this massive, energy-hungry brain with tons of NVIDIA chips. But this is where the stack gets really interesting strategically. We need to talk about the body Tesla, because Tesla is doing something completely different with their hardware.
This is the silicon war part of it, a critical distinction. xAI is a customer. They are buying NVIDIA chips by the boatload. Tesla, though, is pivoting to become a manufacturer. They're building their own silicon.
A total divergence in strategy. Tesla doesn't want to rely on anyone. The sources talk about the AI-5 chip and restarting the Dojo supercomputer project.
Yes, the Dojo 3 project is back on because the AI-5 chip design has finally stabilized. And when you look at the specs, the comparison to NVIDIA is fascinating.
Right, I was looking at the charts. Performance-wise, the Tesla AI-5 is pretty comparable to NVIDIA's H100 or their Blackwell chips, so it's powerful. But the standout stat wasn't speed, it was power consumption.
That is the killer feature, efficiency. A top-tier NVIDIA chip consumes somewhere between 700 and 1,000 watts. A very thirsty chip.
I'm Tesla's AI-5.
About 250 watts.
Wow, that's a massive difference. A quarter of the power for similar performance. Why does that matter so much? Is it just the electric bill?
It's about the application. Context is everything. NVIDIA chips go into data centers plugged into the grid, like Colossus. But Tesla chips need to go into cars and, more importantly, robots.
Ah, of course.
When you're putting a supercomputer inside an Optimus robot, power density is the only thing that matters.
You can't have a robot that drains its battery in 10 minutes just by thinking about walking across the room.
Exactly. And you can't strap a liquid cooling tower to its back. If Optimus is going to walk around your house and fold your laundry, it needs to run cool and efficient. It has to be an athlete, not a furnace.
But there's also a business reason here, the closed-loop economy.
Right. Supply chain sovereignty. By producing these chips in-house, Tesla breaks its reliance on NVIDIA. If they want to make millions of Optimus robots or robotaxis, they cannot be waiting in line for chips like everyone else.
They want to control their own destiny.
Precisely.
There's also a difference in what these computers are learning. I think that's important to clarify.
That is a vital distinction. Colossus, the xAI machine, is a training monster for general intelligence. It reads text, learns logic, studies history. It tries to understand the world conceptually.
And Dojo.
Dojo is a video processing supercomputer. It's not reading books, it's watching the road.
It's watching millions of Tesla vehicles, learning physics, object permanence, real-world autonomy.
It's the difference between reading a manual on how to drive and actually driving a million miles. One gives you the logic, the other gives you coordination. Both are critical for the stack.
So we have the brain running on massive NVIDIA clusters and the body running on efficient custom silicon. Let's move up the stack from hardware to software, because for you and me, this is where we'll feel the change first. The sources describe a shift from chatbots to agents.
This is the user experience revolution. We are currently in the era of passive tools. You go to ChatGPT, ask a question, it gives an answer, it waits for you. It's a tool.
Like a calculator.
Exactly. We are moving toward active interns or autonomous agents.
I like that intern analogy. So instead of a tool I use, it's a worker I assign a task to.
Precisely. Think about it. A tool helps you do the work. An intern does the work and brings you the result. But to do that, the AI needs a different kind of thinking. The reports on Grok 5 highlight something called System 2 thinking.
System 2, from cognitive science, right? Daniel Kahneman.
Correct. System 1 is your fast, instinctive reaction, 2 plus 2. You say 4 without thinking. Current chatbots are mostly System 1. They predict the next word.
And System 2 is?
System 2 is slow, deliberate reasoning. It's solving a complex math problem, planning a logistics route.
So Grok 5 is designed to pause, to think.
It's designed to stop, plan, verify, and then execute. It's not just talking, it's thinking through a workflow before it acts.
That sounds slower. In a world obsessed with speed, isn't that a step back?
In human terms, yes. But they manage it with a specific architecture called mixture of experts. The source material notes it has 70% sparsity.
Sparsity. Okay, can you give me the simple version of that?
Sure. Think of it like a massive hospital. You have thousands of doctors, each a specialist. If you come in with a broken toe, the hospital doesn't send every single doctor to look at your foot.
Right, that would be chaos. They just send the podiatrist.
That is sparsity. Even though the model has 6 trillion parameters, it only activates the specific expert nodes relevant to your query. This keeps latency incredibly low, sub 120 milliseconds, despite its huge size.
So it's huge, but it's nimble. And it has one other massive advantage that the sources keep mentioning. The data itself.
The fire hose.
Access to X, formerly Twitter, 68 million tweets a day.
And people often dismiss that as just noise, but for an AI, that data is gold. It provides situational awareness.
Right. Most models are trained on data sets that are months or years old. They're smart, but they're living in the past.
Exactly. If a major geopolitical event happens right now, a standard model won't know about it. Grok has real-time access to the global conversation. It's the difference between asking someone who read a history book and someone who is scrolling the live feed.
And that structural advantage, especially in finance and news, is where we start to see the real-world economic consequences.
This is where things get really serious. We need to talk about computality.
It's a heavy term.
Yeah.
But before we get to the philosophy, let's talk about our jobs. Source material is pretty blunt about who's in the crosshairs.
And it's not who people usually think. For decades, we assumed robots would come for blue-collar jobs first. But robotics is hard. Building hands is expensive.
But electricity is cheap.
Exactly. So the real target is cognitive labor. Reports, coding, legal strategy, data analysis, the intern replacement.
That brings us back to that agent concept. If the software can do the job, not just help me draft an email, but write it, send it, file the response, and update the spreadsheet, the structure of a company changes.
The need for human staff consolidates. You don't need 5 junior analysts gathering data for a PowerPoint. You need one senior person managing a fleet of AI agents who do it instantly.
The sources mention Grok 4.2S, and of course that's the version number being tested in stock simulations.
And generating curiously high returns. This threatens high-frequency trading, financial analysis, fields we used to think were safe because they required brain power.
So if the AI is doing the thinking and the executing, what are we doing?
We shift from being processors of information to being auditors. In a state of computality, the machine produces the output, the code, the brief, the strategy, and the human's role is simply to check it, to sign off on it.
That's a fundamental shift. You're not the creator anymore. You're just quality control for the machine.
And if we connect this to the bigger picture, Musk's prediction is that this leads to a post-scarcity economy.
Right, where the cost of goods and services drops to near zero.
Follow the logic. If AI drives the cognitive cost down to zero, and robots eventually drive the physical labor cost down to the price of electricity, production becomes incredibly cheap. This could necessitate something like universal basic income because traditional employment becomes optional.
It's a wild vision, a world where work is optional because the stack is doing everything. Let's ground this back in reality. When is this supposed to happen?
The roadmap is aggressive. According to the timeline, early 2026 is the release of Grok 5 with those AGI-level capabilities. That's also when they target high-volume Neuralink manufacturing.
So, essentially next year. We aren't waiting long.
And by late 2026 or 2027, Dojo 3 is expected to come online, running entirely on that in-house Tesla hardware.
So we're looking at a convergence, xAI's brain, Tesla's body, and the Neuralink interface, all hitting their stride around the same time.
It creates a self-reinforcing ecosystem, and the takeaway for you, for the listener, is about the gap that is forming in the economy. There will be AI-native firms that integrate these workflows immediately.
And traditional firms that don't.
And the sources imply that gap is going to get very wide, very fast. You just cannot hire enough humans to compete with a gigawatt of compute.
It's a lot to process. We've gone from a server farm in Memphis, through the cooling pipes, into the silicon of a robot, and to the complete restructuring of the labor market.
That's the nature of the Singularity stack. It connects the infrastructure directly to the economic outcome.
So what does this all mean for us? I guess we better get good at auditing.
Or learning to direct the agents. The skill set shifts from doing to directing.
Well, there you have it. The Singularity stack isn't just a roadmap. It's a warning shot and an invitation to adapt.
Indeed.